Greetings, math fans. All right, so this is day one of 314 Algebra 2, and for chapter 1. Okay, so this was actually my first video for 314. And, all right, so let's just kind of get started here. So let me kind of label it here. This is chapter 1, day 1. All right, so the first thing we're going to talk about, a lot of the stuff is review, math fans. All right, so we're going to talk about something called rational numbers and irrational numbers. So rational numbers. And basically, a rational number is a number that can be expressed as a fraction. Okay, so fraction, 2/3, 5/2, whatever. It can be a fraction. So let's kind of do some examples, and then I'll make it almost a little bit easier to understand what rational numbers are, as opposed to just say something that can be expressed as a fraction. So if I give you the number 4, 4 is a rational number because I can express that as 4/1. I mean, I can do it a lot of ways. I can say 8/2 if I want. I could say, 50, or if I could say 500 over 125. Okay? So, I mean, there's like a zillion ways that you can say 4, but as long as I can express it as a fraction, you don't have to go so complicated. You can say 4/1. Okay? So even like 2.3. So let me give you a little bit more, because you're saying, Mr. Curtis, that's 2.3. It's not, you can't have that fraction. Actually, I can actually write it as 23/10. Because if I take my calculator and type in 23 divided by 10, I get 2.3. So I truly can write this as a fraction. So here's a deal. Decimals are okay. So decimals are okay if they end. So if it ends, it's like, I could say 2.7316518. That's a rational number. Okay, because it ended. There's nothing here. It's not like it keeps going. Okay. If it repeats, so something like 2.838383, and then there's like a line over that 83 repeats, that's okay too, because it's repeating the same numbers, and that makes it a rational number. That you could turn that into a fraction. Okay. So it can be anything. So 3.1111111, that's a rational number. All right, and that keeps going, ... So these are all rational numbers. So let me give you a couple more, like 0. 0 is a rational number because I can turn 0 into a fraction, 0/1. That's easy. Okay, if I said 0.6 with a line over it, again, that's the 0.6666666. That's a rational number as well. Okay, those are all rational numbers. Square root of 16. Well, you're like, wait a second, about square roots. Well, remember, guys, if this is a perfect square, if that's a perfect square, it's a rational number. If it's not rational. We'll talk about that in a second. So a number that can be expressed as a fraction, decimals are okay. But it's like I said, it's got to end or repeat. If it repeats, it's okay too, like this is okay, and this is okay. Okay, so those are all rational numbers. So let's look at an irrational number. Okay, an irrational number is really numbers that can't be expressed as a fraction. So it's kind of it's the opposite of what a rational number is. So I'm just going to write this out here. Numbers that can't be expressed as a fraction. Okay? Numbers that can't be expressed as a fraction. So most numbers that you kind of look at are going to be rational numbers, because all those examples I gave you before were all rational numbers. But like, for example, the square root of 6. If I type in the square root of 6 in my calculator, I get 2.449489743. There is no repeating here, right? It's all different numbers here. So this is irrational. Okay, that's an irrational number. Square root of 5, same thing. Square root of 3, square root of 2. The ones that are rational were the ones that were perfect squares. Square root of 4, square root of 9, square root of 16, square root of 25. Those are all rational numbers. Okay? This is an irrational. And what is another irrational number that you guys all learned out back in geometry? Okay? Pi. It's upside down smiley face too. Okay? So pi, 3.1415926, blah, 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 blah. It keeps going. There's no repeating of any numbers. It keeps changing and changing and changing. That is an irrational number. So this is probably the best example. Radicals, pi, those are kind of the best thing. So again, if it doesn't repeat, so doesn't repeat. Okay, that's going to be a nice irrational number. Okay, not bad, not bad. Okay, so the next topic here is basically adding and subtracting positive and negative numbers. Okay, I'm gonna let you guys use your calculator, which is great. Okay, but you kind of really have to know how to use your mind just to do basic adding and subtracting positive and negative. So we're gonna kind of go through this real quickly, and then I'm gonna show you this on your calculator. I've got a picture of the calculator. At least I can show you what buttons to push and whatnot. Okay, so this is just add and subtract. All right, and it's positive and negative numbers. So here, first thing we're going to have here is if it's got the same sign. We're going to have two categories. Same sign. So same sign means like 5 plus 2 or negative 5 minus 2. Now some of you guys you're hearing negative and minus, and so what you guys need to understand is a minus and a negative really are the same thing. You probably learned that in Algebra 1. Okay, they're not. There's nothing different. It's like I said, like 0 minus 2 is negative 2, or just negative 2, right? Negative 2, 0 minus 2, it's all the same thing. Okay, so just kind of keep that in mind. All right. So anyway, if it's got the same sign, you notice that 5 is positive and the 2 is positive. The negative 5 is negative, and the negative 2 is negative, or the 2 is negative, right? They're all negative or both positive. So what you do is you add, this is kind of the rule here. So I'm going to break this up and we're going to have two categories. So we're going to add the positive parts together. You're going to add the positive. So you're going to say positive, so it's 5, 2. They're both positive in the first place. So 5 plus 2, okay, is 7. Now the second part, so that's the first thing. You're going to add the positive parts together, and then you're going to use the sign, S-I-G-N, of the larger number. Okay, you can use the sign of the larger number. So whatever the larger number is, that's the sign of your final answer. Okay? So I'm going to say, like for this one, it's 5 plus 2 is 7. What's the sign of the bigger number? Well, if the bigger number is 5, it's positive, so my answer is 7. So this is equal to 7. Okay? Let me get rid of this line in front here. I'll move that line in a second. Okay, so it's equal to 7. It's pretty easy. So let's do the next one. Negative 5 minus 2. Well, what's 5 plus 2? Remember, only add the parts to the positive. 5 plus 2 is 7. What's the sign of the bigger number? Negative. The answer to that one is negative 7. It's like super easy. Super easy. Okay? So that's with the same sign. You add them together and then use the sign of the bigger number. So if you have opposite signs, okay, rule number 1 is the only one that changes. So in other words, if I have negative 5 plus 2 or 5 minus 2. So they're opposite signs. So 5 is negative here and 2 is positive, and this one is 5 is positive and 2 is negative. Okay, so if they're opposite signs, the only step, again, the different is step number 1. You're going to subtract the larger, and these are larger positive, minus the smaller positive. Okay, because you can know how to do that. That's easy. So like for the first step here, you're going to say the larger, again, we're looking at the larger numbers here, so 5 and 2. So of course it's 5 minus 2, right? That's the larger minus the smaller, and that's equal to 3. Okay, so that's what you do for the first step. And the second step is this step. Use the sign of the larger number. So for the first problem, it's 5 minus 2 is 3. And what's the sign of the bigger number? Negative. So this is negative 3. Oh yeah. Okay. And 5 minus 2, you all know, but let's just apply the rule. It's, again, the bigger number minus the smaller number, so 5 minus 2 is 3. What's the sign of the bigger number? Positive. So the answer is 3. Okay? So those are your two different categories. Same sign and opposite sign. If it's the same sign, you add them together. If it's opposite sign, you subtract. And you always use the sign of the bigger number. Okay? So let's do a bunch of examples here real quickly, because really it's pretty easy. Like if I had 7 minus 12. Again, I see they're different signs. The 7 is positive, the 12 is negative. So I subtract. 12 minus 7. This is in your head. 12 minus 7. Everyone can do that. That's 5. What's the sign of the bigger number? Well, isn't it negative? Because it's negative 12, right? So the answer is negative 5. If I did 12 minus 7, again, you all know how to do that. Okay? But I could make it a little more complicated. Say, instead of saying 12 minus 7, I can say negative 7 plus 12. That kind of confuses people a little bit sometimes. But who cares? Opposite signs. What's 12 minus 7? 5. What's the sign of the bigger number? Positive. It's right. That's positive. So the answer is 5. Okay. Negative 3 minus 8. Same sign. Add them together. 3 plus 8 is 11. What's the sign of the bigger number? Negative. Boop. Negative 11. Okay. 14 minus 17. Opposite signs. Subtract. 17 minus 14 is 3. What's the sign of the bigger number? Negative. Answer is negative 3. What? That's it? God. Okay. Really not bad. All right. So that's kind of a little summary for for adding, subtracting positive, negative numbers. Let's go to let's just like real quickly multiplication. I mean, you guys should remember if you have 2 parentheses 3, that's of course the same thing as saying, oops, 2 times 3, right? So the answer is 6. And of course, if one's negative, like 2 times negative 3, that gives me negative 6. If they're both negative, that's going to be positive 6. Multiply 2 negatives, you get positive. Multiply a positive negative, you get a negative. Okay? That's pretty easy. And if I do more, if I said, 2 times negative 3 times negative 4, well, I got 2 negatives here, so it's going to be positive. So 2 times negative 3, negative 6. Negative 6 times negative 4 is positive 24. If this one was also negative, no big deal, right? What's the final answer going to be? Well, these are going to give me a positive, and then times another negative is going to give me a negative. So I know my answer is, in this case, negative 24. Okay? So it's pretty easy. All right. So what I'd like to do now is kind of show you a little, I want to show you like even some fractions real quickly. Right? So if I type in, first of all, fraction is just division. That's all it is. All right. So if I said 28 divided by 4, that's 7. I can say 28 over 4. It's the same thing as division. That's equal to 7. So it's the same thing. Okay. So what I want to do is just kind of remind you of a couple things, and then just show in your calculator. Again, I don't have a live calculator on my screen here, but hopefully I showed you some stuff in class, and you can ask questions. But you need to get to know your calculator, because if you're going to take the SAT, you really need to be well versed in your calculator and kind of know what's going on, because a lot of it is calculator based. All right, so we need to know that. So real quickly, if I did, let's just do 2/3 times 5/4. So if you remember, I mean, you really multiply straight across. So 2 times 5 is 10, and 3 times 4 is 12. And then I can reduce that. Right? 2 goes into 10 5 times, 2 goes into 12 6 times. So my answer is 5 over 6. If one of them was negative, then my answer is negative. If they're both negative, this guy and this guy are negative, then 2 negatives multiplied to give you a positive, then this would be a positive 5 over 6. Really pretty easy. Okay? So this is kind of what I want to do, the way I want you to kind of deal with this. If you start with a fraction, so start with a fraction, then your answer is also a fraction. Okay, so if you start with a fraction, I want your answer to be a fraction. So, you know, if your answer came out to be, let's say you did some work and you came up with 1/2, don't give me 0.5. Okay, stick with fractions, because what's going to happen is you really want like exact answers. So if you had like your answer really came out to be 1/3, your decimal would be 0.333. And if you give me this, you're kind of off by a little bit, because you're really supposed to continue this on here, math fans. And 1/3 is really an exact answer. Okay, so if you start with a fraction, I want your final answers in a fraction. All right, so let's take a look real quickly at the graphing calculator. This is what most of you guys have. If you have a graphing calculator, then just come talk to me sometime. Okay, I'll show you how to use a graphing calculator. Most kids don't have it. This is a nice, inexpensive calculator. It's like $15 or something like that. You can get it at, you know, Walmart, Target, Amazon, wherever. All right. So basically, I'm just going to kind of point to things here. Hopefully you guys can see. This is my little pointer here. Okay, but you're going to type in everything, obviously, by typing by the number keypad here, and see there's under, you have division, multiplication, subtraction, addition, and equals. This is a minus sign. So if I say like -2, I actually have to hit this button right here under the 3. Negative, let's say I want to say -2 plus 5. I have to hit negative right here, -2. Well, let's actually do it this way, -2 minus 5. So -2, then you got to hit the minus 5. If you hit -2, -5, it'll give you an error, because it doesn't know, it's not smart enough to know that. You have to do -2 minus 5, and then to get your answer. Okay, so that's just kind of one quick tip. And the other thing is, see this button right here? It's the you got the DRG, and then the PRB, and then the ABC, like the fraction button. A lot of you guys probably know how to use that fraction button. Okay, that button is like super handy. Okay, what that does is it allows you to type in a fraction. It allows you to get an answer as a fraction, and so you want to like kind of play with that button a little bit. Again, I don't have a working calculator here for you, but hopefully I showed you in class how to work this calculator. But basically, let me show you something. All right, so real quickly, if I type in, let's say I want to type in 2/3. I basically I hit 2, I type 2, and I hit that fraction button. Okay, the A, B, C. What that does is it gives me like a little mark like this, 2, and then hit 3, and that actually lets me type in 2/3. Okay, if I want to type in 2/3, and then I hit the times button, 2/3 times 5/4, and hit enter, it'll give me a number. It'll give me like if you multiply that out, you get 10/12, which is 5/6. So it'll actually reduce it, and it'll give me 5. I think I'll actually say 5/6. Okay, so that's kind of nice. I can also type in, like, let's say if I want to type in 1 1/2, I can do 1 and 1/2. Just knows what it's doing. It's 1 and 1/2. That's what 1 1/2 is. Okay, so I can type in, we call 1 1/2, this is a mixed number, and if you get an answer of, like in this case here, I could do 3/2, and 3/2 is called an improper fraction. All right, if you notice above that, it says A and then B/C. If you look above it, it's got A, B/C with an arrow back and forth like this, and then it's I can't quite read it. What that is? I don't know. That's not the clearest picture. Whatever it is, let's just say it's BC. B/C. So what this does is, if you hit second, so this is important. So if you hit second and that key and that ABC, this A, B/C, what that does is it converts it between a mixed number and an improper fraction. So if you get 1 1/2 and you hit second ABC, it converts it to 3/2, and you hit it again. And you have to hit and then you have to hit enter. Don't forget to hit enter, and it'll convert it back and forth between the two fractions. It's kind of a cool feature. It's kind of a nice feature on your calculator. Okay, so again, if you have questions about that calculator, come talk to me and I'll help you out with your calculator, but it's really good to know how to use your calculator. Okay. Anyway, so that's kind of just a little brief intro of some of our topic for day one. So anyway, have an outstanding day, math fans. Adios. Goodbye.